All right, we're back. We're on page 326 out of 329, so we're really getting there. We are on part B. If you were with us for part A, you watched me completely flub this second derivative here, and then that led to some problems on my sign chart, and consequently some problems with my graph. But eventually, we got our stuff together, and we're able to finish it. Hopefully, you were with us for that. Who even knows? All right, so here, the limit as x approaches infinity of f of x is actually just 0. So therefore y equals 0 is a horizontal asymptote. So you dive right in, right? So we got our horizontal asymptote. Vertical asymptotes, we want to factor f of x. That's 1 over x plus 1, x minus 1. We want a sign chart for this. So -1 and 1. It's a sign chart for f. Negative a billion gives me negative times negative is positive, so positive. Everything is first degree, so we're going to alternate as we go through. Some people find that risky. I mean, as long as you're doing it right, you're going to get it right. But if you're not sure, test the regions. Like plug in 0, plug in a billion, plug in negative a billion. Like it'll work. So we can say that the limit as x approaches -1 from the left of f of x is infinity. Therefore, x equals -1 is a vertical asymptote. We can say the limit as x approaches +1 from the left, let's say, of f of x is -infinity. Therefore, x equals 1 is a vertical asymptote. So vertical asymptotes are the most annoying because you know the answer ahead of time. And like your job is to verify it, to prove it beyond a reasonable doubt, beyond any doubt, actually. So we have that. All right, let's do our f prime, f double prime. Let's try not to mess those up. But like, no one intends to mess it up. Just kind of happens organically. All right, so f prime. I'm going to switch colors. So f prime of x is the bottom, x squared minus 1, times the derivative of the top, minus the top, which is 1, times the derivative of the bottom is 2x, over the bottom, which is x squared minus 1 squared. Okay, so what does this give us? That's negative 2x over, this is not going to be a pleasant second derivative to take, over x squared minus 1 squared. All right, and we can do a sign chart for that, but I'm going to hold off and do a stack sign chart. So f double prime. This is not going to be great. F double prime. Bottom, so x squared minus 1 squared, derivative of the top, minus top. So let's not get that wrong. Don't forget your negative signs. Got to put them in. Derivative of the bottom. So I have to expand the bottom to like be able to do that. I'm going to do a little side problem here. Okay, so we need to find the derivative of the expansion of that. So I'm going to expand it. X to the fourth minus 2x squared plus 1 is 4x cubed minus 4x, which is 4x times, what am I even doing? Because I'm just going to have to like, no, I guess having it in factored form is probably useful. I don't really know. 4x x squared minus 1. Maybe there's something we can do with that. Oh yeah, there's x squared minus 1s everywhere. So maybe there's something we can do with that. So let's say this is 4x times x squared minus 1. So I can take it. I think I can take an x squared minus 1 out of both of those. Equally likely that I have messed up, but we'll find out. And then x squared minus 1 to the fourth, because you have to square it. Okay, so what can we do here? We take out x squared minus 1. So let's do that. You could also take out a 2. So I'm going to take out -2 and then x squared minus 1. -2 x squared minus 1. Okay, which leaves me with x squared minus 1 from the first thing. And then it leaves me with, I took out -2 and x squared minus 1. So I'm just left with, I think, negative 4x squared. This is risky. I think that's right. Minus 4x squared over, I'm going to be pretty happy if I just get this right. X squared minus 1 to the 4th. I'm not going to be able to find the zeros of this, by the way. Like, I don't think. I mean, maybe I will. Hard to say. Let's get this out of the way for now. Where should we put it, though? Let's put it over here. I'm pretty confident that I don't need all this space down here, so I'm going to keep, like, moving vertically. See what happens. All right. So I feel like I should check this, though. So I took out x squared minus 1 and negative 2, which left me with x squared minus 1. I took out x squared minus 1, and I took out negative 2, which leaves me with x times 4x. But it's minus, so I think that's right. So now I can actually cancel the x squared minus 1 with one of the x squared minus 1s in the denominator. So let's do that. So I'll have negative 2. I'll have negative 3x squared minus 1, which actually has no zeros, so that's good. And then I'll have x squared minus 1 cubed. I don't know. Let's go to the calculator and see what it says. That was a tough one. They're a lot harder when you're talking your way through them. I mean, I know that sounds like an excuse, because it is, but it's still the truth. Like, it is harder to find these things when you're talking. Let that be a lesson to you for when you're in class. Like, if you are talking during class, you're losing out on an awful lot of your education. F of x. So take out a negative 3x squared plus 1. Ooh, got it. We got it, guys and girls, everyone involved. Got it. I wanted to, like, become a y'all person. I think I said in one of the other videos. Because it feels like gender neutral, and I feel like that's an important thing in the world. I probably just lost a lot of people watching because people can't deal with that. All right, let's do our sign charts. Okay, so we need one for f prime, and we need one for f double prime. So f prime, I'm going to have 0, 1, and negative 1. So negative 1, 0, and 1. F double prime, only negative 1 and 1 need to get involved. Negative 1 and 1. The numerator is actually always positive because it's always a negative times a negative for the second derivative. All right, for f prime, we got to scroll back and forth a lot, and that's very annoying, and I apologize. Also, my face is in the way, so I don't know if I can do it, but I'm going to try to put it down here, I guess. Let's see. All right, so if I plug in negative a billion, oh, the denominator is always positive, so this is good. Negative a billion will just give me a positive. So positives. And then like negative 1/2 will also give me a positive. And then any positive will give me a negative. Okay, so far okay, I guess. F double prime, we said the numerator is always positive. The denominator, if I plug in negative a billion, I get like 1 billion cubed, so I get positives. If I plug in 0, I get a negative. And if I plug in a trillion, I'm going to get a positive. Okay, so increasing concave up, increasing concave up, increasing concave down, decreasing concave down, decreasing concave up. That decreasing concave up, something like this. We also have all of our asymptotes. We have asymptotes at 0, negative 1, and 1. All right, I think we can do this. I think this isn't actually that bad. So here is our axes. Negative 1 and 1 are vertical asymptotes. 1 and 1 are vertical asymptotes. Y equals 0 is horizontal asymptote. And then our curve is increasing concave up while like respecting the asymptotes. If I plug in 0, what do I get? 0 gives me negative 1. So I just want to do that to like have a little bit more accuracy. Here to here. And then here. All right. Whew. That's it. I think that's our graph. All right, I'm gonna do the next problem because like, why not? We're here. If my face moved, I'm gonna try to move it back. It may never have moved. I don't really know where it goes while I'm recording. I do know, so e to the x has a very interesting derivative, which maybe we haven't run into before. The derivative of e to the x is e to the x. What? So there's like a thing that people like, be the change you want to see in the world. E to the x like models that, right? Because the rate of change of e to the x is e to the x. It is its own rate of change. So that's kind of neat. But let's find some derivatives. So f prime first, derivative of the second, plus second, derivative of the first. Okay, let's factor that. So e to the x, we get x squared plus 2x. So that's f prime. Okay, let's find f double prime. It's going to be first, the derivative of the second is 2x plus 2, plus second, which is e to the x, derivative of the first, derivative of the second plus second. Oh, wait. Well, actually, I'm not wrong. It's just, I should rearrange it. So first derivative of the second plus second, derivative of the first. Okay, so I can take out e to the x, and I'm left with x squared plus 4x plus 2. Okay, f triple prime is first, derivative of the second is 2x plus 4, plus second, which is x squared plus 4x plus 2, derivative of the first, which is this. Let's factor that. I get e to the x. There's an x squared plus 4 plus, what am I doing here? So this was, okay, plus 6x, and then plus 6, I guess. First derivative of the second. First derivative of the second was 2x plus 4, right? Plus second, derivative of the first. Okay, first, okay. So there, I think I got them. I don't know. We didn't find enough to, first 4, crud. All right. I was going to say, we didn't find enough to like find a pattern, but it looks like there might be one. First, derivative of the second, 2. So every time you're picking up a 2x and then like I don't like some, it's like n minus 1 times 2, I guess, sort of thing here, plus second. It'd be nice to find a pattern because then you can like generalize it. So this would have been, or is, e to the x, I get x squared plus 8x, and then plus 12. 2, 6, 12. So I added 4, then I added 6. Next time I'll add 8 because of the derivative there. Yeah, I mean, I feel like there's definitely a pattern here that I don't want to spend a million hours on. But that'd be like a really nice challenge. If you figure out the pattern and you want to like put it in the comments or like let me know some other way, that would be awesome. What I'm going to do is I'm going to end this video here. It may be long, it may not be long, I'm not entirely sure. But I will see you in the next video where we will keep going because we're getting really close. And that's very, very exciting. So if you're still with me, good for you. I will see you in the next video.